Welcome to this video tutorial. This video tutorial on polynomial functions and their basic graphs and interpreting them through the calculator. On the screen we have a graph that we're going to look at and we have a window specified. So we turn to our calculator and in the y equals we're going to type that formula. Negative 2x cubed plus 5x minus 1. Next we'll go to our window and we'll make sure it's set as indicated. So the x min is negative 10, the x max is 10. The y min is negative 10, the y max is 10, and we'll hit graph. And there's the picture. So first thing is when we go to write the sketch, all we need to do is just draw basically what it looks like, something like that. It doesn't have to be perfect, it's just giving me a sense that you know what the picture is. Over on the side here, I'm going to draw this picture even in greater detail like this so that we can work with it in just a second. The zeros. Those are the points where the graph crosses our x-axis. It's the point where y would be equal to 0. In order to calculate those spots, we go to our calculator. Second trace to calculate, option 2 is the 0, and we've done this before. So we can enter the left bound, we can enter the right bound, and we take a guess on where we think each one is. You can either scroll, or you can type answers kind of like I'm doing right here. At least 2 decimal places correctly rounded, otherwise I will specify if I want a certain number of places. So here, x equals negative 1.67 is one of our zeros. Another 0, we have to go back to our calculator. Second trace, 0, left bound, right bound I'm going to say is positive 1, and it looks like there's one right around 0, so I'm going to hit 0 as the guess, and it's 0.203, or we could write 0.20. And the last one is going to be the one on the far right. Second trace to calculate, option 2, which is the 0, left bound, right bound I'll put 5, guess I'm going to put 2, and it comes out to 1.47 when rounded to 2 decimal places. Now local maximum points. We've already used the calculator for a maximum before, but we'll do it again. Second trace, option 4 is the maximum. Here's where it's at. So to the left I'll say 0, to the right I'll say 2. I'll guess x equals 1, and there it is. 0.91, comma 2.04. 0.91, comma 2.04, and I'm going to put on the picture 0.91 as the x value. Then we need the local minimum point. So on the graph, here's our maximum. On the graph, here's our local minimum. It's the local minimum because it's the smallest point in that region of the graph. So we second trace to calculate. Option 3 is the minimum. Left bound I'll say is negative 3. That's to the left. You can scroll if you want. Right bound I'll say is 0. I'm going to guess negative 1 for the x. And there it is. Negative 0.91, comma negative 4.04. And over on this graph, right over here, I will put the negative 0.91 because those should help us write the increasing and decreasing intervals. So the increasing intervals are the x values where the graph is going up. Notice the graph is going up here between those 2 spots. So for the increasing intervals, it'll be negative 0.91, comma positive 0.91 with open parentheses or the rounded parentheses. Decreasing intervals. That's where the graph is going down from left to right. In this picture, it's going down from left to right in those 2 shaded areas. Goes all the way to the left, which would be a negative infinity, comma, it stops at negative 0.91 for that run downhill. Open or rounded parentheses on both. Then we put a U, meaning also, or. The word itself is union, and then it goes from 0.91 forever and ever and ever and ever. Rounded parentheses on each of those. Turning points are the combined numbers of maximums and minimums. We have two turning points. It turns around here, and it turns around over there. The degree of this polynomial is 3 because the largest exponent in the equation is 3. For the end behavior, it's going up to the left and down to the right. The domain would be, what are the x values of the graph? Well, the graph goes all the way to the left and all the way to the right. So the domain is negative infinity to positive infinity. And the range would be the y values from top to bottom. It goes all the way down and it goes all the way up. So the range would also be negative infinity to infinity.